Recording is on.
Hi everyone, this is the Ruby Developer Book Club, and today we are covering chapter 5, which is all about errors. So this is chapter 5. We are still covering Eloquent Ruby, and we'll be covering 4 subtopics, namely handling errors with return values, handling errors with exceptions, retrying transient errors, and designing exception class hierarchies. So we'll start with the very first one, handling errors with return values. And here what we are looking at is that instead of, we write a program, and instead of having that program return an error to us, or what we would also call an exception, we get it to return a value instead. And here we see a contrast between two languages. One is Python code, and then another is Ruby. So here we see that if we have a hash and we try to access we try to access a value inside that hash, but with a key that's non-existent. In this case, the key is B. We see that we get an error, and this error is named a key error. Then when you try the same thing in Ruby, we see that we get nil as opposed to getting an error. And this shows you that in Ruby, for this particular bit of code, we see that Ruby returns nil to us, which counts as a value, as opposed to returning an error like we see in the Python version of the code. So we see another contrast between the two languages, and here we are still comparing Python code, and we are comparing another thing in Ruby. So the entire point of this, along with the memorization code that is on page 141, is the fact that when you're trying to access a value from a hash in Ruby, you're going to get nil if the key you're using is not present in that specific hash. And when you try to sorry in this code, you're trying to access a value inside this hash, but using a non-existent key, which is B. The reason as to why Ruby doesn't throw you an error instead is simply because if you were to add another key value pair, in this case B with the key B with its associated value, you're going to end up getting the value that has attached to B, which you've just added. So that is the reason as to why Ruby doesn't throw you an error and returns nil to you as the value when you check inside the hash with a non-existent key. And I think the same applies for an array. In case you are trying to access something in an array and you go beyond the index, the reason being the same, and that is that if you were to add a value at that specific index that wasn't there before, you're going to end up getting the actual value at that index. So before you'll get a nil as the return value, and then after adding that specific value at that index in the array, you're going to end up getting that value. So yeah, that's kind of the thinking behind that. And then here you have a case where that kind of thinking doesn't apply, and you see that here we are creating a new OpenStruct object. And one thing to note is that when we try to access, I think B is supposed to be a method, we get nil. And when we say os.b, we assign it to 1, and then we try to access it again, we are going to get 1 as the result. So you see that, as noted previously, the principle only applies if the receiver were to return an expected result if it included different data. And you see that if the call were to fail regardless of which data the receiver included, then Ruby will be similar to Python in the sense that it will raise an exception. And the next code shows us how that happens. So here you create a new struct object and you pass in A. At any one point, you're not going to be able to access B simply because when you are creating this instance of the struct class, you never passed in B initially. So regardless of the number of times you try to query and access B, it won't be possible simply because at the time of creation, you didn't pass in B. So Ruby will be throwing you a name error as well. And as you can see, it tells you no member B in struct. So primary benefits for using return values to signal errors. The very first benefit or advantage is better performance as compared to the version which throws an exception. And then another one is that if the error is common, it's easier for the user to deal with it instead of forcing them to rescue an exception. And here we look at an example, which is a database query. So we are looking up a row in the database by the primary key of the row. And here you see that we have a method called pklookup. We pass in the primary key, and then we select from the table where the ID is the primary key. So assuming the database.first, which we see inside the query, returns a hash or some other object when the row exists and nil when the row doesn't exist. This is an example of a method that uses a return value to handle an error. And the return value in this case is the nil that is returned when the row doesn't exist. So we'll look at a scenario whereby the method, whereby, let's see, one issue with this method is that it will still run a query even if you know that the query will not return a row, such as when you pass in nil as the primary key of the row. So the preceding code gives you the same kind of behavior. However, it improves performance of the case where the pk argument is nil, though I don't quite understand what this is. I don't get how it improves the performance compared to the one before. Or maybe because it returns unless the primary key is an actual value as opposed to being nil. So if it's nil, I don't think the query will be run inside the database.
Yeah, that's how I understand it.
Yeah. Then we'll move on. The trade-off in this case is that every time you call the method, you cannot assume it will return a valid row. And you can see that code such as passing in 1 as the primary key to the pklookup method will not raise an exception when pklookup is called and there is no matching row that is identifiable by the primary key 1. So we see other scenarios. For example, a case when in normal use of a method you don't need the return value because the method is called for side effects. And here you see we have a method called with the specific query being updating. I think updating, should I call it a row inside the database? Yeah, basically it's performing some updating. However, in the general case, the return value of database.run update is useful because an update can affect more than one row. However, if you are passing the primary key in this case, you are sure that it will never modify more than one row and the return value may not be important. So this shows you an example of how you could use this specific method. You pass in the primary key, and then you pass in the column name as a symbol, and then you pass in the value. And then the author tells us about the problem with this specific piece of code, and that is if the database row with the current ID does not exist. In this case, we are referring to self.id. The method returns 0. However, since you aren't checking the return value, you don't know that this code is making the expected changes. And one thing to note is that you might end up with data loss of a certain sort, because you don't know whether this update method actually ended up updating something inside the database when you called it. And yeah, which brings us to the conclusion. The principle here is to be wary of using return values to indicate errors when the caller of the code does not need to use the return value of the method. So if you don't need to use the return value of the method, then you're going to have to default to the other thing that you can throw towards the user, which is throwing an exception such that the user can end up handling that exception and figuring out what it's about. And that is one way that can help you deal with the data loss that is associated with this update method. Yeah.
One comment that I'm going to make is that the Ruby standard library relies on the return values being nil. It relies on that contract for a lot of the standard library, and you have to get familiar with that approach. In the standard library, of course, they wanted to be very performant, and so that's the style that I went with. So instead of returning like a new object, it'll return nil in case something is updated, or sorry, true or false in case something is updated. Um, and I think that's a good approach. Like one of the uh, of course, like the good thing is that it's faster, and like this chapter pointed out, the con is that it can hide errors because you're not actually forced to check the return values. But I think that's because we rely on, or the standard library relies on this style of coding. I think that's why they introduced the safe operation navigator, the ampersand. So like if you get a nil value back, you have this syntax in the language that is the ampersand that lets you say, oh, we're gonna only if this is not nil are we gonna continue down this path.
Yeah. So I don't know if
Sure.
Miles took any notes on this before I proceed.
Yeah, I could try to just give the more interesting or potentially more interesting parts of my notes is real quick. Back on the page 141, it was interesting to me that Ruby principle about data access, that if the call could work in the future, that it returns nil, and that's like a principle that feels intuitive, but I had never heard it before. So I was kind of just curious how much time goes into thinking about these principles or not, because I'm just kind of curious about the history there. I don't think anyone here knows the answer to that without some research or whatever, but I did take a note of that. And then I was also thinking about in a different chapter, and I think he was talking about singleton methods on classes, and maybe modules, but he talks about the square bracket method, the lookup method, and how you should delay implementing it until you have a better idea of how best to leverage that method. Meaning, I feel like in Ruby there might also be a philosophy that the author mentioned in a different chapter, but not here, which is that square bracket operator should be as useful as possible, and it would have been less useful if you were forced to check the presence of the key everywhere before using it. And so I wonder if part of the design decision there was also just the square bracket operator is more universally useful if we return nil if the data is missing. And then if you want the safety, you have to call a different method with a longer name. And so I wonder if there's a bit of that philosophy as well. So I took a note of that. And then what other note did I take? I think that's it. I think, yeah, I think that's it for that. Like, I took other notes, but I think they've already kind of been covered by other folks already.
Oh, one other thought that I had is that sometimes, because we are sometimes creating nils as we go through our program, sometimes those nils propagate through the program, and it makes it harder to locate the source. Like, where did this nil come from? Was it this method or was it some other method before it? And because sometimes the style that we use hides the errors, it's sometimes difficult to troubleshoot what method actually created the nil.
Yeah, actually, to that point, I totally agree. To that point, I actually thought on, and I think this was the author's intent, and that might be why I didn't take a note of it, but in the case where he does a short circuit of returning nil because the primary key is nil, even though in the future that could return a meaningful result, in my own code, I would still raise an error there. Because if you're passing me a primary key of nil, I'm actually making the assumption that you've made the type of error that Nelson is talking about somewhere else. And I want to shorten the distance between where that nil was incorrectly made and where it's going to finally cause an explosion. So I'm just going to explode right here. So that's a case where I would personally violate this principle. And if you tell me, give me the record with this primary key, and you pass me nil, I don't view nil as a valid primary key, so I'm not going to return nil. I'm going to raise an exception for exactly the reason that Nelson just mentioned. But I don't know the author's intent, and it seems like the author's trying to set up intentionally problematic code for discussion in the future sections here. So I wasn't sure how to interpret the author's intent. But yeah, I would, for the reason Nelson just mentioned, I would raise if you give me a nil primary key instead of returning nil personally.
Yeah, so I think we'll be moving on. So the second subsection is handling errors with exceptions, and here instead of returning a value when an error happens, we instead raise an exception. And we say that when you call the length method and you pass in 1 as an argument, you can get an argument error. Length method is one of those methods that ship with Ruby by default. And then you can also trigger an exception when you pass in the wrong kind of argument. For example, this count method is defined on integer and not string. So when you call it on a string, in this case s, you're going to have a type error telling you there was no implicit conversion of an integer into a string. So the entire point of this raising an exception as opposed to returning a value is we want to do away with a case where the user of the program can ignore the error and proceed with whatever they want to do. So we are going to kind of create like a barrier whereby they have to first deal with this error before proceeding. And by doing that, we can avoid situations, for example, like the update method we looked at previously that result in data loss. And here, the case example that the author introduces, we are designing an authorization system. And here we are trying to check whether a user is authorized to perform a specific action. And we create a class authorizer and create a singleton method that's called check, which takes the user and the action that we are checking for as the two arguments. And then we are basically inside this method, we are just checking whether a given user is authorized to perform a given action. Then we see here one way in which we can use the authorizer class. So we say if authorizer.check, we pass in the current user, and then we pass in the action we want to check for, which is manage users. So if the condition is true and the current user has permissions to do this, then we show the manage users page. In other words, we let them manage other users. If that's not true and the given current user doesn't have the correct permissions, then we show the invalid access page. So the author notes that the issue with this code is that it's very easy to misuse this kind of code that we've just looked at as one way of using the authorized class. And it gives a situation whereby you have a new programmer that doesn't understand the API, and the programmer assumes from a method name such as check that it handles the error by raising an exception. And if I was to scroll, you can see that inside the check singleton method, we are not raising any error. So when the programmer is trying to use this code, this class, sorry, that assumption, you see that you see that he says authorizer.check, he passes in current user and the action, and then he only stops at show manage users page. And the author says that this can be even worse than the data loss that we described previously with the update method, in that you have an elevation of privilege vulnerability in the application. Because I imagine this code is going to allow someone that doesn't have access to do a certain thing to end up doing that specific thing. So now we are starting to make modifications inside the authorizer class, with one of the modifications being introducing an invalid authorization class, which inherits from standard error. And after defining that class before the check method, we are now going to proceed to raise the invalid authorization exception inside the check singleton method if the user is not authorized to perform a certain action. And we see that overall, that's better compared to the version we started out with. And the author notes why this is better, and that is because it forces the user to handle the exception and avoid the case where the failure is silently ignored, like if we had returned a value instead of raising an exception. So he proceeds to give us two principles that you ought to follow when designing an API. One of them being you should not only design the API to be easy to use, but you should also attempt to design the API to be difficult to misuse. And the name of the principle is misuse resistance. So a method that does not raise an exception for errors is easier to misuse than a method that raises an exception for errors. And then another principle he talks about is the fail open design, which basically means that if there is a problem with checking the access of a given user to a specific action, access is allowed, as opposed to the fail close design principle, whereby if we fail to check whether a given user is authorized to perform a given action, the system will not allow access by default, which I imagine is achieved by raising the invalid authorization exception in the authorizer class. Yeah, so this code here on page 148 at the start is, I think, about a case where you need a true or false value for whether an action is authorized. For example, let's say you are showing a dashboard page and you need to know whether to include a link to the page to manage users. So he gives you a version of code known to write, and here we're using begin, rescue, else, end, and still we are performing a check similar to what we've been doing, whereby we are passing in the current user and the action we're checking for, and then we rescue by raising the authorizer invalid authorization exception, and after raising we don't show the link. Otherwise we display the manage users link. He says the code I've just explained prior is a bad approach, and he proceeds to rewrite that code using by defining another singleton method on the authorizer class, which is called allowed. And he proceeds to show you how you can use such a method, and you see that you say authorizer dot allowed, you pass in the current user and the action. If access is allowed, then you show the manage users page, else you show an invalid access page. And yeah, I think that's pretty much it
Yeah,
for that section.
I do like that he points out the method that ends in a question mark and it returns a true or false value. Sometimes I miss having a typed language where you can just look at the method signature and know what the return value is going to be. And in Ruby, the only time where that happens is the question mark. It's nice that you know exactly, like, oh, this method ends in a question mark, it's going to return true or false. And yeah, it's very clear to the users of the library what uh what the return value is going to be.
Yeah,
Maybe one thing
go ahead.
Miles, can you add?
Oh, I was going to say, along those lines, I actually took a note back on page 146. If I'm going to have this check method raising an exception, I actually would have called it check exclamation point, and that would have at least eliminated any ambiguity for me what that check method is doing or what its behavior is expected to be. But because it's check without the exclamation point, that kind of, for me, sort of adds the ambiguity. And I think it's the author's point. Like, I think the author intentionally needs some ambiguous code in order to demonstrate what he's trying to demonstrate. But yeah, I would have defined that check method with an exclamation point to communicate that it raises an exception in case of the user being unauthorized. So along the lines of the question mark, communicating information to the user of that interface, the exclamation point in Ruby is useful as well. Let's see. I took another note on 146 that I feel like, and again, the author is trying to make a specific point, so I think these notes don't really apply. But I also took a note that I feel like in practical reality, generally prior art in the code base would already exist and have been tested, and it's usually the engineer would be using prior art of using the library to create new authorization checks. And so hopefully in reality, the user would not make this mistake, because they would usually be copying and pasting existing authorization checks in the code base that would already be working. But again, I think the author is trying to make a specific point, with which the author does make. I took I guess I could continue just with other notes I took in this section. I took a note about the misuse resistance and the I forgot what it was like the open fail versus closed fail. I've never heard those terms before, but I do something very similar in the way I think about it, which I think is the same concept as the open fail concept. Whenever I have a branch in the code and one of those branches is dangerous and the other is not, I always make the non-dangerous path the default. And like one example I came up with when thinking about working with typical Ruby code is when operating with environment variables, sometimes an environment variable isn't set when it should be, or it's set to the wrong thing, or the person writing the code might forget that environment variable values are always strings, or maybe they check for true, but someone set it to 1. So basically, if an environment variable is controlling whether something dangerous is going to happen or not, I always set it up so that the default action will be the non-dangerous path. And then it winds up, and the author covers this, but then it winds up being discovered that, the code in production is doing the wrong thing because it's supposed to take the dangerous path instead of the non-dangerous path. And then you have to go fix the configuration to make it take the dangerous path, which is way better than taking the dangerous path when that's not what you wanted. So I have like an intuitive understanding of that concept, but to me, it's always been about the default action through the code base should be the non-dangerous action. And that gives, I think, the same result. Yeah.
Yeah,
So
I think it gives the same result too. Yeah.
maybe a question I had is the whole method ending in a question mark thing a convention when it comes to Ruby? Like, what if I wrote a method that ends in a question mark and it doesn't return true or false, but instead it just does something else, a non-true or
You can
false?
do that. Obviously, you shouldn't do it because it's going to be very confusing. But yeah, it's purely it's not enforced by Ruby.
Oh, okay.
Sorry, I was going to ask something too. I think it was Miles that mentioned that he would have used the bang operator for the check
Yeah.
for the check method. So I wanted to ask if that is a Ruby thing or a Rails thing, because I know in Ruby the bang shows that you're trying to modify the thing, but I think in Rails, well, I think it's in Rails where methods like active record methods like save, update, uh, they by default without the bank operator, they don't raise any exceptions, so you don't know if something actually saved or
Well, that yeah,
updated.
that I don't know. I was assuming this was more universal, but maybe it is. It's potential that it is a Rails convention. I'm actually not sure of that. I will say in this case, we're talking about a singleton method on an authorizer class. And because of that, there's not even an instance involved. So to me, it strongly communicates exception instead of modification. So, but it's an interesting thing in that in the case of save without an exclamation point versus save with an exclamation point on an instance that is not a class or a module, that might be a little bit more of a Ruby or a Rails convention. I'm actually not sure. I don't know the answer to that. I would have assumed that it's universal, but you could be right that it's a Rails convention, or maybe it originally was a Rails convention and has become universal. I actually don't. That's a good question. That's a good question that I actually don't know the answer.
Well, I would suspect it's a Ruby thing. It was one of the guidelines in Eloquent Ruby, which was written in 2012, I think. And it's in there, and it just talks about like Ruby programming. There's nothing in there specifically about Rails, and it does mention that convention for both exclamation point and question mark.
Oh wait, does he mention exclamation for raising exceptions, or like throwing exceptions, or for
No, for any dangerous
modifying?
modifications that you're doing on an object, like if you're modifying memory in place, uh, the bang means it's going to change the memory in place, and if it's being if that resource is being held by two agents, then the second agent may or may not expect the value of the memory to have changed underneath them.
Hmm. So I think that's the Ruby part that's obvious to me, and but the part where you wanted to raise, for example, someone new to the code base sees check without a bang and thinks that, oh, this has to return like true or false or something, and does not expect it to raise. So is that, I was asking if that was a more Rails thing to expect the bang version of check to raise an exception, something like that.
So something I'm gonna try. Oh, it looks like Paul made a comment in here. Let's see. Yeah,
Yeah.
something I'm gonna attempt to do just because I'm curious. I'm gonna use that object space thing. I'm gonna find all instances of module in just a plain IRB session and see if any of them have methods. So the hypothesis there would be there should be no modules with a method that ends in an exclamation point because there's really nothing to modify, or you wouldn't expect it to modify, and see if there are any, because I'm actually just kind of curious if there's any examples of this in the standard library, which again, like Nelson mentioned earlier, though, the standard library does have a preference for returning values for performance reasons, so it doesn't necessarily rule it out, but I'll give that a check. Yeah, I will just say that my personal intuition as a Ruby programmer is that that exclamation point communicates something dangerous, which in this case, to me, means, especially because it's a singleton method on a class, that I'm going to get an exception that halts execution if something's not right, and that's what it communicates to me. But what I don't know is if my intuition matches the Ruby like intuition, or specifically the Rails intuition. You now have me very curious to find out, though.
Yeah,
And
I feel you.
and we should probably click on these links from Paul just to see.
Oh yeah, we should.
They could be relevant.
Because I think my intuition on seeing a bang would also be that it would raise an error, but that's like a Rails influence for me. So perhaps it's subjective. But yeah,
Yeah,
I
I'm
think
kind of curious.
all right. I think Newton can move on at this point.
Uh, so maybe to say something about about the bang. So personally, how I understand the bang is that if you have a method, now let's say like some of the methods that come with Ruby by default, now let's say like maybe like the gsub method, and I don't know if it has a bang, if it has a counterpart that has a bang, but if you have a bang at the end of a method, that basically means you're going to be performing modification of some sort, as opposed to performing that specific operation on a duplicate, which is what the version of the method without the bang does. So I don't think I have a similar intuition like Miles and Samuel when it comes to what the bang signifies. In my opinion, it's more of a thing of you're performing this modification on this specific, now let's say, array or class, as opposed to the duplicate of that specific array or class. In other words,
Yeah,
you're modifying data of some sort.
maybe it's because that looks like maybe controller code or something that has to do like a network request. So it makes me think like, oh, if I was in a Rails controller and I was trying to check if my update or if my something was successful or not, I would use the bang. If I usually I would not use the bang because I would I'll do an if statement because I'm expecting like a true or false. But if I really wanted to know if that update failed or something, if that operation failed, then I'll use a bang. So in that case, the bang is not really changing how like what is being done, I would say. Unlike Ruby, where the bang is like, oh, you're modifying this object versus creating a copy, right? In this case, it's just going to raise an exception. Like it. So I think for me, it's a Rails influence.
Oh yeah, maybe
Why I
another way to
think
look
that
at
way.
it would be from this aspect. Like if the bang is at the start of the method as opposed to the end of the method.
Oh, do we have stuff like that?
I think if you have a bang at the start of something, it signifies the negative version of the thing.
Oh, that's
You can't.
a
That's
logical
well.
not or
That's
something.
yeah. That's a different method. That's the unary not operate. That negates true and
Yeah.
that negates the yeah. That's not part of the method. That is a separate method. So like if you do not check, that's two methods. One call to check, and then a call to the bang method to negate the result of the first call. It's not one method.
Ah, okay.
Whereas
Yeah.
check with an exclamation point is the name of the method itself, and it's one method.
Yeah.
Yeah. I think it's interesting, and perhaps maybe later we'll find out if that's
Yeah, but
a
Paul
general
has
thing.
shared some links.
Oh
I don't
yeah,
know if yeah.
I'll check out his links later. They're short articles. I already opened them to the side.
So now we'll be looking at how to deal with one of the key points that the author mentioned when it comes to raising exceptions instead of return values, and that is the fact that handling errors with return values is more performative compared to handling errors with exceptions. So he goes into detail about how to how that performance lag happens, and he gives an example whereby if you have the exceptions get slower in proportion to the size of the call stack. So if your call stack is 100 frames, then it's going to be raising an exception will be slower compared to if the call stack only had 10 frames. And then he says the reason for this is because Ruby does a lot of work behind the scenes to construct the backtrace for the exception. And he said that Ruby needs to read the entire call stack and turn it into an array of thread backtrace location objects. So he gives some examples of how you can improve performance for code that raises exceptions, and one of them is to create an empty array when you're calling the raise method. So you say raise argument error, you pass in what the message you want to raise, and then you pass in the empty array. And then you can also make that version faster by phrasing the empty array prior to raising. So you can say empty array and then you phrase the empty array, and then after inside the method where you're raising, you proceed to pass in that empty array that you froze prior to you raising. And then this is he gives you another approach still, whereby Ruby allows you to construct an exception object manually using an approach as per the following example. So here you create a new exception object by calling argument error.new. You pass in the message, and then you proceed to say raise exception. So with the code I've just described, you can add a call to set the backtrace so that Ruby will not have raise generate the backtrace by itself. So you'll say exception argument error dot new, you pass in the message, and then you say exception dot set backtrace, and then you pass in the empty array like we've seen prior, and then you proceed to raise. And the point of doing this is that you want the code to be more performative as opposed to what you get by default when you don't, for example, use the empty array or try to specify that the backtrace should not be generated. So we look at a downside of this code, and that is the fact that if the code has no backtrace, then it's difficult to debug if you run into problems. And that is the major thing to note about that kind of approach to improve performance. So I'll cover the transient errors bit as well, and then we'll discuss thereafter. So he says it's a fact of life, at least for a programmer. Some things fail all the time, but other things only fail occasionally. So we're going to try to raise for things that fail occasionally, and these things that fail occasionally are the things that are referred to as transient errors by the author. So he gives an example of one of those things that fail all the time. For example, you're trying to call, you're saying nil, and then you say to string, then you pass in 16. So here you get an argument error because you're passing in the wrong number of arguments. So this code is going to fail all the time you try it in an IRB session. So this is not one of the transient errors that he's talking about. But anyway, that aside, we're going to look at transient errors from the aspect of networking. And I'm not really familiar with networking, but basically, when you have a network request, you encounter transient errors. And in case of these transient errors, retrying is one of those approaches that you use to see if maybe the issue you encountered on the first try, if you try again, it won't happen again. So that is the lens from which we are going to be looking at this particular piece of code. So here you say require net HTTP and you require URI, and then the preceding program doesn't handle errors, so any exception raised when trying to download the file will result in an exception being reported and the program ending. So we modify the code to be able to raise by using the begin, rescue, and I think I should call it a loop. So here we begin by calling net http.getResponse. Then we pass in the file we want to get as an argument to URI, and then as part of the rescue, we are going to retry. And then he gives you reasons as to why this code is generally a bad approach, and one of them being that it's a bad idea to retry on every exception type that could be raised. For example, if you make a typo in the protocol name and it will not pass a valid URI. So we want to retry for only specific exception types. And this is the improved version we end up with. So here we are only retrying for socket errors, system call errors, and HTTP bad response errors, as opposed to retrying for all kinds of errors. So now we look at the issues with the improved version. One issue is that just because net http.getResponse, we pass in the URI, returns a value and doesn't raise an exception, it doesn't mean that the value isn't an error. So he tells us that the HTTP protocol supports two kinds of errors, namely client errors or errors that start with 4, for example, I think 404, and then server errors which start with 5. So the returned response could be one of those errors. We proceed to modify the code such that if the response code is greater than or equal to 400, then we retry. And I imagine these are the kinds of errors that are client errors. So we retry for client errors, and then the rest of the code stays the same, whereby we are rescuing for socket errors, system call errors, and HTTP bad response errors. So The issue with this code is that it has a syntax error because you can only call the retry inside in between rescue and end, so you can't use it between begin and rescue. So we proceed to rewrite that even further, such that in between the begin and rescue, we say if response.code to integer greater than or equal to 400, then we raise a net HTTP bad response. Otherwise, we rescue and retry for a socket error, system call error, and then the HTTP bad response error. So now we look at a situation whereby your requirements have changed and you only want to retry on an HTTP client or server error, but not for other errors. So this is what you end up with. You say while the response is equal to net HTTP response, you pass get response, then you pass in the URI. So you break unless the response.code to integer is greater than or equal to 400. And then one issue with this code is that it doesn't really communicate why it's written the way it's written. In this case, it's hard to determine the intent of the code. So we proceed to rewrite it like this. And here we use the redo keyword, but we specify that this block should only run once. So we say one.times do, and then inside we create a response. And then if the response code is greater than or equal to 400, then we redo. So the entire point of the entire refactoring is based around using the redo keyword. And he mentions that the redo keyword is one of those list keywords in Ruby along with the next keyword. So yeah, the advantage of the code is that it conveys the intent better, which basically means that it's very easy for another programmer to determine what this code is trying to do. And he talks about the fact that it's possible to use a proc or a lambda as opposed to using the one.times do end block. However, the proc or the lambda are both associated with increase in performance when you compare them to one.times do end block.
Well, I was going to mention, so I took a note somewhere. I don't see it in my notes, but I pretty much always avoid retry, and I either do a loop or a recursive call. I tend to do, just because I sometimes forget the details of the mechanics of things like retry and redo, and so instead of making use of them, I just do something a little that I already know how it's going to work. But regardless, I tried break and next with a proc object, and it gave me an error. It gave me a local jump error, and it was because like proc objects are closures, so they've been copied to the heap, and they can't really meaningfully unwind the stack, so you get an error. So I don't know if that's something new, or if there's a way you can, like a context where you can successfully do it. But just for the heck of it, I actually tried it out, because I always get confused by when I can or can't use redo and retry, and exactly how they're going to work, and exactly which block. So the other thing is that I think break and redo and next also work with for loops and while loops. And so since I don't have all of the rules memorized of how these keywords work, I actually just wind up not using them personally. But yeah, I did take a note that the author mentions that you can create a proc or a lambda and just call it. But when I did that, I got a local jump error. So there's a difference between the block being ran within the call stack and the block being copied to the heap, where it can't really jump back in the call stack trace, or at least not reliably. And I guess that might not entirely make sense what I'm trying to communicate there. The real point being that I couldn't successfully create a proc or lambda the way the author mentions here. I had other comments too on the earlier sections that I could talk about before we move on to retrying, but I could let other people talk first.
Maybe a question I have is about, remember when he talked about the call stack and how you basically have slower code if you raise exceptions as opposed to returning a value. I'm curious about how that ends up happening.
Well, that was something that was interesting mentioned in the book that I had never thought of before. So it makes sense that it would be slower just because the mechanics of how it works is more complicated than returning a value. And I think that's what you're really asking about. However, he specifically mentions that the thing that really slows it down is constructing the backtrace. And I think there's like no way to lazily construct the backtrace because once you've rescued the exception, the call stack has been unwound at that point. So Ruby doesn't know if you're going to make use of the call stack or not. So it has to preemptively construct that giant array of strings. And I think the author's main point is that's really what's slowing it down. Not so much the mechanics are slower, meaning I think it has to jump backwards to a previous stack frame, which I guess I actually don't know, but I'm assuming. So in the last book, when we learned about the jump table or whatever, there was some kind of special table that kept track of what to do with keywords like return. There was a list of them. It was like return, retry, redo, break, next. That might have been it. That might have been the full list, but these all use a special table inside the YARV stack frame, and I forget the details, but it could be that this is more expensive than just returning a value from a method, which all returning a value from a method does is that method is somewhere on the stack, and it's just gonna set the stack pointer to, if the stack pointer is not in the right place, it usually just pushes it on the stack. And then when the method returns, it's just pointing to the top of that. But
if I remember correctly, the call stack is a linked list, so you have to traverse the entire linked list from the start. You can't just go to the end of the linked list. So it's everything that your program ran, and then it'll take the last few things.
Yeah, I think you're right. And also I think that if I remember correctly, that linked list isn't just the method calls, it's all the nested blocks too, that it has to traverse through. So it's not
RB control frames.
Yeah. So it's that's probably it. Yeah, it's a giant, it has to traverse a potentially large linked list. But yeah, interestingly, the author mentions the building that backtrace object, and I had never thought about that before. But in retrospect, it's kind of obvious that would be slower than just returning a value, especially when the call stack is really deeply nested. And I think the author mentioned somewhere, if you're using like a web framework like Rails or something, then almost always you're usually very deep in the call stack when you're running your application code if you're using any sort of framework. So that was interesting. And I had never seen the technique of passing an empty backtrace to speed things up. I've seen set backtrace used before, but that's usually because when you're creating an error in one spot but raising it in another, and you want to accurately reflect where you created the exception instead of where you raised it from. I've never seen it used as a performance improvement. I took a note that I have a question about that, which is that if a library is using this type of exception handling for control flow internally, I wonder if the throw catch usage of Ruby is more appropriate than raising an exception in order to avoid creating that backtrace. So actually, throw is probably another one that uses that jump table, that linked list of jump table stuff or whatever, or however it's actually constructed. But yeah, I'm actually kind of curious about that now, and I might even reach out to the author and ask them since the author's point of view is so library centric, if an exception is never meant to escape from the library, I wonder if throw catch. I wonder if that. I never really used throw catch in Ruby, but I wonder if that's actually a good use case for throw catch. Is you otherwise would be using an exception that never escapes the library to the calling code. I don't know if that's interesting to anybody else, but I took a note of that because it's just interesting to me.
Maybe a question I have is, how would you debug such code when you don't have a backtrace?
It'd be difficult, probably. Yeah, I
don't. In my opinion, I feel like the performance benefit is not really that great if you end up with code that is very hard to debug.
Well, one thing you might do there is control it with like a flag or something, or maybe only in production do you strip out the backtrace, particularly if you can configure it to be turned on. So you could have a situation where if you feel pretty confident about it, you skip building the backtrace, but having a way to get the backtrace for debugging if you really need it. I mean, that would be one option. I've never done this. I've never skipped building the backtrace for performance reasons. So actually, maybe it's very rarely even necessary. It could be kind of a premature optimization sort of situation. So I guess usually if I'm in an exceptional situation, I'm not really worried about latency anyway. I'm more concerned with why is an exception being raised than the latency. But yeah, it's interesting stuff. But yeah, to answer your question, it would make debugging harder. So I would either make it configurable or have it only applicable to one environment or something.
Yeah. Also, another question I had was the code on page 153. He mentions that you see this URI variable. So when you take it outside the loop, apparently that improves performance.
There's two things here. One is it improves performance because you don't have to construct that object on every retry. Another more important thing, actually, that I think the author is mentioning, or at least I think either the author mentions it or is implicitly communicating it, that URI call might raise an exception of some sort. And so this code does two things. It avoids reconstructing the URI on a retry, but it also avoids any potential for accidentally rescuing an exception from URI, which we do not want to do. This code is trying to catch exceptions that arise from get response. Because URI is outside of that begin block, we cannot accidentally rescue and retry on a URI error. So I think there's two good reasons that the author's trying to communicate for moving URI out of there.
Yeah, there's I don't know, I think it's one of the previous chapters that we covered whereby he gave an example similar to this concept of taking the creation of the variable outside of the loop as a way of increasing performance. Though I don't remember which chapter specifically.
Yeah, it might even have been in multiple chapters because it's any code that could be called multiple times, like methods. There's places in the code where he's moved things out of methods into constants, so on and so forth. So it's kind of a recurring theme that it's faster to do something once than to do it multiple times.
Yeah. So
I think it was probably okay.
No, I was actually going to say I'll proceed, but I guess you have a question. So
I just wanted to say that one of the things you're remembering might be the where he created a cache to just standard like memorization to avoid creating that object over and over again.
Yeah. So the next part is about more advanced retrying, and here the author starts by saying that retrying an infinite number of times is basically a bad idea. So we want to come up with a reasonable number of times that we can try before we end up giving up on the retry. And here, this specific code specifies that we retry 3 times, and after retrying for 3 times, if we still end up with an error, then we proceed to raise. And you can see that that is denoted by this line, raise if retries are greater than 3. And above that line, you see that you keep on adding 1 to retries until you reach a value of 3, which is the cutoff. So he says that you can also restrict the number of times that the program should retry for as part of the times block. So here you're retrying for 4 times as opposed to running the block once, as we saw in the previous section of the code. So another thing to note is that you also want to create some time between subsequent replies. So for the first retry, you want to retry, and then you make the program sleep a bit, then you retry again. So the time that is taken in between subsequent retries keeps on increasing. And here you can see that we are making the program sleep for 3 minutes or 3 seconds before retrying again. But then he notes that the approach is too simple in general, and that in most real-world applications, you increase the amount of time between each retry. So yeah, I think this is still he gives you like a kind of simple way to achieve that increment in time that you take to sleep between subsequent replies. And here you can see that he's performing some operation whereby you multiply 3, which is the cutoff, times 2, and then you exponentiate by the number of retries minus 1. And by the number of retries, I mean the current number of retries. So this could be 2 minus 1, or 3 minus 1, or 1 minus 1 if it's the very first retry. So in this part, he gives you kind of like what he calls a thundering hard algorithm. No, he gives you a classic exponential backoff algorithm to solve the thundering hard, whereby a large number of processes are retrying at exactly the same time and overwhelming the server. I'm not really familiar with how this works, but I think it's just simple math, because I can see he's multiplying 3 by 0.5 plus run divided by 2. Then he still performs a multiplication on the right side still. So it's kind of similar to this kind of code that we have here, whereby we get the number of retries minus 1. So we could say that it's kind of a more advanced piece of multiplication compared to the previous one. So breaking circuits. Here he's talking about a related problem to retrying exceptions, which is that you have code you want to run, but it isn't critical to the success of the program. So he gives you an example whereby you have a payment processing service that also makes calls to a recommender service and an ad service. So he writes out a circuit breaker, which is directed to terminate calls to the recommender service and the ad service if the program has retried 3 times and the recommender service plus the ad service are still failing. So yeah, the rest of the subsection takes you through how he thinks about writing that broken circuit class. And I think I'll proceed to cover the last subsection, which is designing exception class hierarchies. And here you have he says if you're writing a library and raising an exception in it, it's useful to have a custom exception subclass that you use. So here you have a method called foo, and we say that unless a bar is allowed, we are going to raise bad bar. Yeah. So he modifies the code above and writes it in such a way that we have a class called error, which inherits from standard error, and then we end up using that error class when raising inside the foo method. One thing he talks about is that it's always a good idea to have a general error class. Like you only have one class named error which inherits from standard error. And then if you need more specific exception classes or error classes, those classes can then inherit from the error class, as opposed to you having the multiple exception classes all inheriting from standard error. And the point of having those classes inherit from the one error class is that it will make your code backwards compatible, as opposed to the alternative. So yeah, how will you know which exceptions deserve separate exception classes and which exceptions don't? In many cases, you won't know unless you have a very clear idea that a particular exception should be treated differently. So yeah, he gives a case whereby a user has presented this code to you and you proceed to write a bar error class for them, which they can use inside this begin rescue end block. And then he talks about using core exception classes. He notes that the code on page at the end of page 164 is not idiomatic Ruby code, because Ruby for one object, when Ruby is performing a method calling on an object, it doesn't really care about the type of the object, but rather whether the object responds to the method. And I think that's what is referred to as dark typing. So he says that it's a bad idea to have that kind of code which is raising type errors, and you should instead just call the method on that specific object, and if Ruby has a problem with it, then it will let you know, as opposed to you defining that it should raise type errors. So the questions: main advantage of using return values to signal errors, more performative. Main advantage of using exception classes, less likely to cause data loss and less likelihood of the errors to be ignored. Why is it important not to retry transient errors immediately? Oh, I've forgotten this. When is a good time to add a subclass of an existing exception class? I think the answer to this is when it's needed, because he talked about never being sure of when to do that. And yeah, I think that's the end of the chapter.
For the transient error question, the my assumption would be that since we're like the example he gave was network problems, well, you have to give the network time to resolve itself. It's if you try it immediately, it's probably going to fail again immediately. And also, if you have to space it out, because if you don't space out your retries, then you're gonna someone can attack your site. You can get a denial of service attack by just having your web server perform more work than it would by default.
Wow.
Didn't he talk about the specific? Oh, there was a.
Yeah, he talked about it. Is it thundering?
I forget the term he used for it though.
For what concept?
For like
DDoS
some sort of
stuff.
denial of
Mhm.
service based on
Oh, yeah, yeah. Sam was saying it's a thundering herd problem.
Doesn't
Oh,
really
yeah.
hurt
I've
you.
never, yeah, I've never personally ran into that because I usually that kind of problem I'm going through workers. Usually the workers get kind of overwhelmed and backlogged, and so they just kind of naturally start spacing things out until they can clear stuff out. Um, I've never personally needed. I've definitely had to do the exponential back off for sure. I've never really needed to. I've never ran into the thundering herd problem personally. Like the system just kind of naturally throttles itself. Um, so I've definitely had to write code like this, but I've never added the random part in, which makes sense to do. It's just I personally haven't ran into that problem.
I see.
I mean,
So
Yeah, the equation of,
when you're
oh, go ahead.
sorry.
I think it
Also,
happened
if I
recently with
understood you
NPM.
correctly,
Oh,
okay, yeah.
sorry. Go ahead.
Sorry.
Go ahead, Sam.
Okay. All right. Now I was just trying to understand what Miles was saying. So it means that when you're without accounting for spacing them out randomly, and if your job's server gets overwhelmed, it doesn't affect your web server at all, and that just like resolves itself eventually. Like they
Me
just get
personally.
backlogged. Hmm.
Yeah, because
That makes sense.
what winds up happening to me is like, let's say I sleep, 1 second, and then I sleep. Let's just say, well, let's just use the example in the book. Say I do 3 and then 9 and then 27, and then let's just say I give up after that. Um, let's say I wind up with like 100 things that fail, and wind up back in the queue 3 seconds from now. Like I just don't have enough workers running to process those 100 jobs. I might only have like 2 or 3 workers running, and they are not gonna chew through all that stuff in like 9 seconds or 3 seconds or whatever. So just naturally my systems wind up throttling themselves through the natural overhead of processing the work. So I basically get a randomness anyway because I don't have enough workers to retry everything all at the same time anyway, generally speaking. Like my workers,
Makes
like the
sense.
workers are going to be, they're like, and they're handling other jobs too. They're not blocking. They're like, one thing about this code here is it's actually blocking the process. Usually in this case, I might sleep 1 second and retry once, but I personally in my code, if I need to like actually sleep 27 seconds, I'm going to put it in a worker queue. I'm not going to block the web server for 27 seconds, I'm not even going to block it for 1 second unless I'm in a threaded web server. Yeah, if I'm in a threaded web server, I'm totally fine with blocking for 1 second, but I'm not willing to block for 27 seconds, which means it's got to go into a worker queue, which means it has to come back out and compete with all the other work being done. And so there's just going to be they're adding a random number between 0 and 1 to that 3. And I feel like I'm kind of getting that to some extent anyway, just through the nature of the worker queue being a choke point. So just for myself personally, obviously in a different arrangement, this could be a problem. Just in my personal career, I haven't ran into this problem.
It makes sense. So you're talking about npm, Nelson.
Oh yeah, yeah. I mean, there were some recent examples where some npm packages expired. They put in new packages. Everyone pulled them down at the same time, and it caused a whole lot of chaos because you have everyone trying to pull down the same piece of software at the same time. You create your own DDoS.
Makes sense. Yeah, I don't think I heard about that. But makes sense. Yeah. Yo, for some reason, I struggle to understand how the circuits were working initially. And when I figured it out, I was just
But-
like,
That's another
obvious.
approach
I was
I've heard.
wondering
Yeah,
how it was gonna. Go on, please, Mouse.
I was going to say that the circuit breaker approach is also an approach that I rarely have ever needed to do something like. Again, it kind of just comes down to latency. I don't really want to wait 3 seconds for like 2 different external services to potentially fail. So usually in the systems I've built, like typically the web browser is going to separately ask for the advertisements, and then it's going to separately ask for like the recommendations. Like I rarely would have one like controller action that's responsible for handling the request, fetching the advertisements, and fetching the recommendations. That would be 3 independent requests that would all happen in parallel, and the front end would be responsible for deciding what to render if the advertising service either gives an error, or doesn't reply in the time that it would like it to reply. So again, the circuit breaker approach just hasn't, and again, it could totally come up in other projects. It's just never come up in the type of projects I work on, because I would wind up, that to me would be 3 independent services coordinated through the front end, through its event loop. Like it would be automatically parallelized and independent. It wouldn't be something where like, the advertisement service is down, now they can't apply for a loan. Like I would never block someone from like applying for a loan because the advertisement service is down, because I wouldn't want the loan service to even know that an advertisement service exists. So I just wind up not having that problem in historically in my project.
Now, this makes me curious. Do you, for some of those projects you talked about, or most of them, are they a separate client application or something full stack?
Well, I've done both.
Rails,
so I've done both, but like in the situation where I'm doing back-end rendering, the way that a project like this would work is front end would make a request, and it would get so how to explain this? So the front end would get, in the case where I'm doing front end rendering, it's pretty obvious, so I won't talk about that scenario. In this case where there's back end rendering, the back end will usually render some sort of placeholder or something in the template that translates into HTML that communicates to the front end that it needs to trigger these other 2 services. And this would be in the views, and the controller action would have no knowledge about it. And the front end would react to that by fetching 2 additional pieces of markup to render separately in 2 different requests. So if I'm doing front end rendering, it's literally 3 requests with independent rendering through something like React. But if I'm doing the back end, then there will usually be some kind of JavaScript that knows to go fetch markup. And I think like today, there's popular thing, I don't know if Hotwire addresses this, or I don't even know exactly what Turbo is. I haven't used those advanced features of modern Rails. But I think Rails today actually has these concepts of making an independent request and fetching separate markup independently to then dynamically drop into the web page. So yeah, for multiple reasons, regardless of whether I'm doing back-end rendering or front-end rendering, I wouldn't. Just because I'm doing back-end rendering wouldn't be enough for me to couple the application service with the ad service and the recommendation service. I would still have those be 3 separate controller actions, even if I'm doing back-end rendering. Like one way or another, I would figure out. Like one way or another, either using Rails features or writing my own little JavaScript snippet to accomplish it. One way or another, I would have those be. I would do that instead of a circuit breaker approach, personally.
I feel like backend rendering, like with Rails full stack, I feel like that makes it easier to want to do something badly designed like this, as opposed to something like React or Vue on the client.
Well, it could be well designed. Yeah, I think.
Oh, okay. It's not
I,
necessarily badly designed.
Yeah, I don't think it's necessarily badly designed because I think it depends on the project you're working on. If you're working on a fairly simple project and the ad server and the recommendation server have really good uptimes, then I think it can totally make sense. Like you're basically saying I'm in a couple of these three things, but it's worth the pros and cons are better than decoupling it. Like it really just depends on the situation.
I see.
So I guess I should qualify what I was saying before. I guess what I would say is if I really feel like if I'm like, thank goodness we have this circuit breaker in there, then I've probably waited too long to engineer a better solution. But if I'm like, we threw in that circuit breaker and I don't even know if we're using it or not, then it's like, who cares, right? I mean, it only matters if it's like causing pain. So yeah, I wouldn't say that it's necessarily bad design because the opposite could also be true. It could be that you decoupled these three services and now the system feels over-engineered. So it really is case by case. I should clarify that.
Okay. Makes sense. I just find that maybe it's because things like Hotwire don't have enough examples out there. So someone that's relatively new might not know exactly how um, to do what you described, right? Where the client, based off of the response, even in the Rails full stack app, knows to make separate requests for the ad service and the other one. So they might be more inclined, I feel like, to do something like this without even thinking about whether it's a solution or not.
Yeah, and it could be the right way to go, or it could be you don't know what to do, so you just do that, and then you discover you need to refactor it. And I think that's all fine. There's nothing wrong with that.
Yeah,
So just to clarify,
true.
I'm definitely not saying it's a bad design decision to couple those three things. It's just not something that's happened in the project I've worked on. But it's totally valid in
Okay.
other contexts.
Yeah.
Yeah. I do have a bunch of other notes, but I don't know how much time we have. Should I ramble off my remaining notes, or should we
Yeah, I'm curious to
call
hear
it?
your notes.
So
Yeah, I'd
I
like to
took a
hear it.
note. Yeah, I took a note that I've always felt, and this doesn't affect me anymore because I've been using Ruby for so long. When I first started using Ruby, it was really surprising to me that the term exception and the term error are used backwards from my intuition. So like you can't rescue exception, but you can't, like by default you can't rescue exception, but you by default can rescue standard error. And for whatever reason, maybe it's influenced from other programming languages, but it just seems like the exceptional situation is what I want to handle, and I'd be less likely to want to handle the error situation. But regardless, doesn't really matter. It just took a note that it feels backwards to me in Ruby. I took a note that I accidentally have been using argument error instead of type error. Not that that really matters. And there's a use case that I've ran into for having different exceptions in a hierarchy that the book doesn't mention, which is that exceptions are just classes, and so you might have like a class that you might have an error that has different data than another error. So like imagine you had an error related to HTTP. There might be certain snippets of data you might want to put on that error, like data from the request or who knows what, that you wouldn't want on standard error. So I think wanting to put data on an error object is one use case that the book didn't mention. Let's see what else. Almost done. I'm almost done. Oh,
Wait. I have a question about standard error.
Yeah.
Is the
Yeah.
Ruby standard error at all connected with the terminal standard error?
I didn't think so. I hadn't thought about that. They have the same exact name, but I had never thought of that before. So I don't know. I can't see the behavioral connection. Like, but yeah, that's interesting. They do have the same name, but I had never thought of that before.
Okay.
About what you just said, because I think I was thinking about this while I read the book. If you were to add more information to the error,
Mhm.
maybe more contextual information, would that be able to serve as a replacement for the backtrace? Like, would that enable you to skip generating the backtrace since you kind of know what happened based off of the error that was raised?
Not
Does it make
necessarily.
sense?
It might. I mean, it might because, well, I mean, even just knowing the name of the error class might be enough. Especially, so if the error is only raised one place in the code, that can help. Although there can be like 100 different paths that lead to that. I guess long story short, I would say no because I think they answer different questions. Because the backtrace tells you where did this error come from and how did we get to that point what path did we take to get to that
To
point in the
get that.
code. Yeah, which it seems like
Yeah.
independent information than like, you know, like some detail about the, you know, the HTTP request or something.
Okay. Yeah, it makes sense. I was wondering if oh yeah, it makes sense. I think only in the case of a request will that provide some useful information. I feel like maybe based off of like what controller was this from, and
Well,
maybe what action.
I can give
Okay.
an example from my own life. Like, so I work on this project where you accomplish things with commands. And I have a distinction between an error that occurs because there's a problem with an input to the command versus a runtime error that occurs while the command is executing. And the input errors include information about which input the problem is with. So like maybe
Mm.
you take like a fairly complicated set of inputs. It'll include information about the path to the input that was actually problematic. I could embed that in the error message somehow, but then it's harder to use it programmatically. So that would be like
Oh
one
yeah.
example. If it's like a runtime error, um, I don't care about as much information as if it's an input error, because if it's an input error, I do want to know which input was problematic that prevented us from proceeding versus a runtime error, which is, you know, not related to a specific input. So that's like an example that comes to mind of where I might want some data on an error. I mean, you could always pile all of it in the error message and then parse it out. I just don't, that's not like the greatest interface. And actually in the book, I don't know if you remember this, but in the book, he mentions start with one top level error for your library. So at least users can catch all errors from your library and distinguish them from errors from other libraries. But then he
Yeah, I remember.
mentions if you have users doing this and he shows rescuing the top level error class from your library and then they actually like do a pattern match against the error message to branch on behavior. Like that's a really good example of where you would want a new error class. Um,
Mm.
but I guess I would add, if you wind up at a situation where you can't solve every possible thing you would branch on with error classes, you might actually need some data on the error that you could then branch on. And then that's where I would want to put some kind of data on the error class. Another thing I took a note of is that it's kind of the duck typing thing he mentions is not universal, and he mentions that it's like a usually kind of thing, not an always kind of thing. But one thing that sticks out to me is that the error hierarchy approach is explicitly the opposite of duck typing, where we're branching based on the type of the error. We're not asking the error what methods it responds to in order to decide what to do. So error hierarchies are like a real obvious example of not using duck typing. So that's just kind of like an interesting thing to me that we're talking about duck typing, but then also the error class hierarchy is an example of not using duck typing. Which
interesting.
just makes sense.
What?
It makes sense. I'm just pointing out that not everything is handled by duck typing.
Oh, I see. Sorry, did he mention duck typing in this chapter?
Yeah, he mentions, and it's a good point, when he's talking about the type error, he's mentioning you shouldn't check if the argument is an integer before trying to add 10 to it. You should just add 10 to it and let some other thing handle that. Including if it might even just result in a no method error if you accidentally passed in nil or something that doesn't respond to the plus method. So basically the idea of duck typing is if the object responds to the plus method, then just send the plus method. Don't care about the type of the object itself.
Yeah.
But what I'm saying is the idea of the hierarchy, using the exception hierarchy is, so you either go with the approach that what the object is based on what it can do, which is duck typing. The other option in object-oriented programming that's really obvious is just like, what class is it? Like, what is it? Like, is this thing this or is it that? And so when we are using the exception classes, we're branching based on the class, which you could think of as the type. Basically, if you're branching on the type of an object, you're not doing duck typing.
Yeah. So that's kind of interesting because earlier in the book, he's like, don't care about type checking unless it's actually needed. Like if you leave it to happen and maybe Ruby itself runs into a type error while trying to do that thing, then it will raise, instead of you defensively writing your method to. And then here in the another part of the chapter, we see where it's important to care about the error type, right? I think that's interesting. Makes sense.
Yeah, sometimes you don't want to use duck typing, and sometimes you do. And I think in Ruby, like by and large, duck typing is more popular and common than in other object-oriented programming languages, I would say. And it makes sense. It gives you like an easy way to plug in a new object into a working system without having to worry about the inheritance hierarchy. But sometimes you want the inheritance hierarchy. Sometimes that gives you the superior design. So you have to make decisions about what you want to do. And in the case of this error class usage, it is based around class hierarchy. It's not based around duck typing. Which is fine. There's nothing wrong with that, but yeah.
Yeah, that's interesting. I'm going back to the backtrace thing. I was wondering if controlling the depth or the amount of frames could be useful. I don't know if there's a good way to know how much depth you might need, unless there's a way to. I don't think it will be performance anymore, because what if the depth you set is not enough and you want to like request for more? Then it would have captured everything in the first place, and then it wouldn't have been a performance optimization, maybe a UX thing instead. Okay, don't worry. I'll just
one thing that might happen, I don't know, I actually don't know how this is implemented, but if you did something to try to control the depth, it might make it even worse. Because what you might have to do is call the caller method, which gives you the backtrace, and then take like the first 10 elements. So now Ruby has to make this like 500 string array to give to you to tell you what the call stack was. And now you're adding the additional creation of a 10 element array to then give less of a call stack in your exception. So it might be that just makes it worse because now you're allocating one more array. Like if Ruby has to build the whole array for you to then filter it down,
like what's
that
the point?
that wouldn't make any sense. You may as well just give the whole array then, because it would be more performant and more informative.
Yeah.
But I don't know, actually. I don't know how Caller works. It might even have like a lazy evaluation kind of thing or something, but I doubt it. But yeah,
Yeah.
um, I
Perhaps I
am
was thinking
interested.
more front end, like
Yeah, I
showing the
am interested
backtrace
in.
to the user.
Yeah, I am interested in this throw catch thing because I basically never used throw catch. And reading this chapter, it dawned on me that hey, and I mentioned this earlier in the conversation, so maybe not the best use of time. But maybe
You
if you
did.
have an exception that's only used internally to the library and not meant to escape, that maybe that's like the perfect use case for throw catch because you really don't care about the call stack at that point. You're actually just abusing the exception system for control flow, and if you're abusing the exception system for control flow, maybe that's the exact use case for throw catch.
I mean, um, what? Yes, you. The that's a way to recover from errors, but um, like, and some errors you cannot. You it can't be avoided. They're going to come up, but I feel like part of me is like, hey, don't if you're using it for control flow, it's really really easy to start putting things in there that don't belong in exception handling just because you're using it for control flow.
Yeah, yeah. I think it might only make sense in situations where the you really need to unwind a call stack and unwinding it through return values is problematic for some weird reason. Um, so yeah, I think it would be a very rare. It should be a rare situation that you would want to do it. But yeah, now I'm curious, so I'll look into that because I'm actually just kind of curious. But yeah,
Yeah, so next week we're going to be covering chapter 6. I don't know who wants to take up that, and also how what the number of pages we'll be covering.
All right, Sam, do you want to do it?
It's actually
it's
very
fewer.
short.
Yeah, it's fewer pages than chapter 5, so we may as well just do the whole
Yeah,
chapter.
it's 12 pages.
No, not 12. Uh,
Oh,
I think wasn't it 22? Wait, let me look again. Oh,
All
you're
right.
right. It is only 12 pages. It's super short.
yeah, it's
If,
very short.
if Sam doesn't volunteer, I will.
Okay. So yeah, I think that's it for today.
Formatting code for easy reading. This might require like so I know that um, there are a few libraries to do formatting of code. Um, it might be worth covering more than what's in the chapter.
Yeah, I mean, we could do that considering it's so short. So, oh, you mean? Are you suggesting we read chapter 6 and 7, or what?
Oh, is there? What's chapter 7?
Oh,
Or
never mind.
elementary
If
level.
that's not what you were,
No,
if that's not what you're referring to, then never mind. Okay,
no,
never mind.
because it looks. I just skimming through. It looks like he's only covering RuboCop. But it might be worth covering the new Ruby language server. Um,
Okay.
there's other tools that have come out since this book was published.
Yeah, if you do you happen to use those, Nelson? Because you could kind of just demo them if you're already using them.
I don't already use them, but I know they
Hmm.
exist.
Okay.
Will you share some of the resources we'll use, Nelson? Oh, I'm not familiar with the Ruby language server. Is that what they call LSP?
Yeah.
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 My editor, my editor makes use of it, but it automatically does the formatting through Rubocop and not the language server. I don't know what the relationships between all the pieces are, but I know if I remove Rubocop from my current workflow, I will not get any formatting. But it could be there's a way to use the LSP server to accomplish it.
I'll talk about LSPs a little bit in general, and
Okay.
and then Rubocop, and maybe
Okay.
whatever else
Okay.
I discover on my journey.
Cool.
Okay.
Oh, yeah. Okay. See you guys next week.
Okay. Take care. Bye, everybody.